Assalamualaikum warahmatullahi wabarakatuh. Today we will present about characteristic of DC Moto. First of all, I will introduce my group members. My name is Faris Hakimi bin Zulkifli.
My name is Muhammad Syahmi bin Suhaimi.
My name is Muhammad Shafiq bin Mauzair. Okay, motor comparison. DC motor have two. First, worded field, and two permanent magnet. At a worded field, series DC, shunt DC, compound DC, and at permanent magnet, iron core, surface wood, and moving coil. Wood field one field DC motor. In the one field motor, the magnetic flux is generated from the current flowing in the starter winding by varying the supply voltage of 5 current. The magnetic field can be varied. The one field motor can be subdivided into series, shunt, or compound in design. This is a image of series DC motor has high started torque but could be unstable at no load. This is shunt DC motor has good and linear torque speed characteristic. And this image is about compound DC motor has high starting torque at and flat torque speed characteristic. Okay, about permanent magnet DC motor, the permanent magnet motor make use of permanent magnet to generate the starter magnet field. Hence, the starter magnetic field remains essentially constant to all level of armature current. The PM motor can be further classified according to the armature design. There are three types. First, iron core motor. Second, surface one motor. Third, moving coil motor. This is iron core PM motor. PM material can be very ferrite, alnico, or rare earth compound. And second, laminate rotor structure that contain slot for amateur conductor. And third, relatively high rotor inertia, high inductance, low cost but reliable. This is surface 1 PM motor. First, amateur conductor bound to the rotor structure. Second, no slot, hence no closing. Third, usually have large air gap than the iron core PM, hence require bigger magnet. And last, lower inductance and more expensive. And next, moving coil PM motor. No moving iron in the magnetic field. Second, the amateur conductor are placed in the air gap between a stationary flux return part and permanent magnet. And at the third, very low moment of inertia and very low amateur inductance. PM motor have some significant advantage over the one wood field types. A, higher power density. B, linear characteristic. C, no need to generate magnetic flux. And D, high stall accelerating torque.
Motor equation. Torque developed by motor. First, the unit for torque is going to be Newton meter. Second, this look very similar to the unit for work, joule, but is equate difference. Third, so energy and work are in joule and torque is left in Newton meter. T equal K IA for field motor, T equal KT IA for PM motor. Where the torque is in Nm, torque constant KT in Nma, flux in YB, armature current in impress. Voltage indicate across the armature, E equal KW forward field motor, E equal KEW for PM motor. Where the voltage is in V and voltage constant KE is in V if the torque and voltage equation are each solved for common factor under one operating condition, then KT equal KE, power developed by motor, P equal TW, T for torque of motor, W for speed of motor. Torque generate acceleration to overcome inertia. dA equal JA, where the inertia J is kg and the angular acceleration A is in radius. Next.
Equivalent circuit of a DC motor armature. The armature of a DC motor can be represented by an equivalent circuit. It can be represented by three series connected elements E, RA, and VB. The element E is the back EMF, RA is the armature resistance, and VB is the brush contact voltage drop. In a DC motor, the current flows from the line into the armature against the generated voltage. By applying Kirchhoff voltage law (KVL), V equal to EB plus IA RA, where V equal to motor terminal voltage, EB equal to back EMF, IA equal to armature current, and RA equal to armature current resistance. The equation 1 written above is called the fundamental motor equation. It is seen that the back EMF of the motor is always less than its terminal voltage V. The equation can also be written as shown below. V equal to EB plus IARA plus VB. This equation 2 is considered or applicable when the voltage drop VB in the brushes is also taken into account. That's all our presentation today. Thank you.